Hello, this is Edexcel's C4 June 2008 paper. This is the question 7. This question is all about the partial fraction. Sorry, I just had to close the menu on my phone. Hey, whatever that is, think over there. Okay, so we're asked to split 2 over 4 take 4y squared into partial fractions, and you may go, how the hell are we going to do that? Because normally when we split up to something into partial fractions, we've got, in this case 2, and we'd have it over 2 factors, or 3 if that's required. So we'd have it over 2 take y, 7 plus y, etc. You get the idea. And we'd put a over the first factor is plus b over the second factor, etc. But we've not got a first and second factor, we've just got 4 take y squared. Well, obviously this 4 take y squared is a quadratic, which is 2 factors, okay? So we need to split it up into a quadratic on the bottom, okay? And the only way to do that, well, obviously it's essentially 4 plus 0y take y squared, okay? So we need to get rid of the y's, and the only way you do that is by splitting it up into the quadratic at the bottom. 2 plus y times 2 take y, because we've got negative y squared, and this makes splitting up it into partial fractions a lot easier. So it's just a over 2 plus y plus b over 2 take y. Now we're not going to end up with a and b in that order, and you'll see why in a minute. But as I said, you're just now working out as you'd work out any other partial fraction question, okay? So the way I think about it is you times both sides by the denominator of the fraction you're splitting up, okay? So on the left hand side we're just left with 2, and because we're timesing this by 2 plus y and 2 take y, the 2 plus y is cancelled, so therefore it's just a times 2 take y. Similar things happens with b, but we're just left with b is times 2 plus y, okay? And then we just choose a suitable value that will get rid of one of the factors and leave the other factor for us to cancel down, okay? The first factor we're going to get rid of is a, okay? So we're going to make 2 take y equal to 0, so therefore y must be 2. So therefore if we make y 2, 2 equals, now we could write a times 0, but that would be pretty pointless. And it's just 2 is equal to 4 times b, so therefore 4b is equal to 2, so therefore b must be equal to a half, okay? Do a similar thing with the find a. We make the other factor equal to 0, so therefore y must be minus 2, so therefore 2 is equal to a times minus 4, sorry, so therefore a must be equal to, negative 4a is equal to 2, so you divide both sides by negative 4, so a is negative a half, okay? Oh, sorry, that's incorrect. I do apologise. Let me shut myself up. Because it's to take negative 2, we add 2, so they are both a half, okay? So a is a half and b is a half. I do apologise, but, you know, at least I corrected it straight away. But, you know, all of that was obviously to see if you're paying attention, as I always do when I make an error. Okay, so that's part A. Now we'll just split it up into partial fractions. What I would do is write at the top here, where the fraction is, okay, just write a half over both of them. Okay, so it's a half times 2 plus y, sorry, half over 2 plus y plus a half over 2 take y. Now you could have easily just moved this 2 on the bottom, so it'd be 1 over 2 brackets 2 plus y, and 1 over 2 brackets 2 take y. Now, it's up to you. As I said, I left it as that. It doesn't really matter. Okay, but that's the way you really want to see it. Okay, so the next question looks as though it's almost completely unrelated, but you have to be very, it actually helps to be in the mindset of how can I make this question part B. Sorry, I should write it up. I'll write the question up and then it'll make sense what I'm trying to explain. Okay, so we're asked to solve the differential equation 2 cot x dy dx is equal to brackets 4 take y squared, okay? Now, it's very hard. The first thing that jumps to your mind, or should jump to your mind, is trying to convert, whenever you see a function like cot x or sec x or cosec x, you always try and make it as though into the functions that we all know, okay? Now, obviously cot x is 1 over tan x, but if you put 1 over tan, sorry, cot x is 1 over tan x, which is obviously cos x over sin x. But if you put cos x over sin x into there, you'd make it horrendously complicated. It's just easier to put it as 2 over tan x. Remember, it's not 1 over 2 tan x, because that'd be a half cot x, okay? So it's 2 over tan x. dy dx is equal to 4 take y squared. Okay, now what we did originally, we need to, this is what worked out in part A, and we ended up getting this. Okay, and the reason we do this is so we can integrate. If you tried to integrate that, it'd be very difficult. Okay, but we know what the integration of that, we know how to split that up into partial fractions, which we can integrate using ln's, obviously. Now, you need to spot that this 4 take y squared, we've done it something similar to it in 7a, split it up into partial fractions, okay? Because if you try to integrate that, you might do it with respect to x, but you'd end up trying to rearrange it to get the y on the right-hand side, and it'd be a complete and utter horrendous mess. Surely a lot longer, definitely a lot longer than this method, okay? We know it's 2 over 4 take y squared, so that's ideally what we want. But on the left-hand side, we've got 2 over tan x, and on the right-hand side, we've got 4 take y squared all over y, if you can imagine that. Now what we're going to do is times both sides by tan x, and similarly at the same time, we're going to divide both sides by 4 take y squared. Okay, so just switching these two around really, is essentially what we're doing. And they're not going to ask you how you came to that, but as long as you're not skipping out too many steps. So therefore 2 over 4 take y squared, and obviously we times both sides by this dx, okay, and then that's equal to tan x dx, okay. And we're going to integrate both sides. Okay, but we can't integrate that straight away because we still have the same problem as we will do before, okay? What we need to do is write the partial fractions in on this side, okay? But we still leave the integration sign there. So the integration of a half over 2 plus y plus a half over 2 take y, and that's all with respect to y, okay? And that's equal to the integration of tan x. Okay, so it's just a case of using your knowledge of integration to work all of that out. Now, on this side, well, it's what we do is the ln of the bottom, okay, so the ln of 2 plus y. Don't forget, it's modular signs inside this ln because we're always going to ln a positive number, okay? But because the differential of 2 plus y is 1, obviously with respect to y, and we want a half, essentially, as I said, the reasoning behind this I've explained in the topic video, so if you don't get this, I'm just trying to give a brief overview, please do check out the video. So the differential of 2 plus y is 1, and what we ideally want is whatever's on the top, in this case, a half. So what we have to do is divide it by 2, or in other words, times it by a half. So there's a half ln 2 plus y, plus the same sort of thing, however, sorry, not necessarily plus, we don't know that yet. Okay, so the ln of 2 take y, the differential of that is minus 1, and what we want here is we want a half, okay? So what we do is we're going to end up taking it away because it's a negative. So, what am I talking about? I shut myself up, please do. I do apologise. Sorry, 1 second. I think I'm going to a bit of a hash for this. My answers, do apologise. I'm obviously not more slick than this normally. Oh, God's sake, I'm way back in the answers. Great, brilliant timing. Yeah. Okay, because what we need to do is so it's the ln of 2 take y, sorry, I was right, I just thought it was wrong. The ln of 2 take y, and because the differential of this is minus 1 and we want a half, we have to times it by negative a half, so in other words we take it away. So a half ln 2 plus y take a half ln 2 take y is equal to, and if you look at the integration for tan x, you will see it's ln sec x. Okay, and obviously we add plus c onto that. Okay, Now what we want for the answer to this question is we just simply want it, we actually want the particular solution, okay? We're given boundaries when y is 0, x is pi on 3. So if you just write that somewhere on your page, when y is 0, x is pi on 3. But we need to work out this c, we need to work out this constant first. Now, to be able to do this, we need to go back and recap what log rules were. Okay, so when we add logs, we times them, and when we take away logs, it's the same as dividing them. And the reason we can do that is because, I don't know if I point it out over here, we've got a half ln and we've got a half ln. So, I mean, if they were different, then you would just turn them to the powers, and then you would work it out as you normally. But because of the same powers, we can just, in powers in terms of a half times that and a half times that, we can just work it out as if that was 1. Okay, so if you go ahead and do that. Sorry about that, I just had to go and check something. Okay, so when you take away ln's, it's the same as dividing them. Okay, so what you do is you do half ln and you do 2 plus y over 2 take y. So it's half ln of 2 plus y over 2 take y. Okay, and that is equal to ln sec x plus c. And then to get c, we sub in our boundary conditions of y to be 0 and x to be pi on 3. And the shorthand of it is you would get c to be equal to negative ln2. Okay? And then it's just a case of rewriting this equation with c being negative ln2. Okay? So, as I said, hopefully you can understand that. It's a simple case of subbing numbers in y to be 0, so it's half of ln of 2 over 2 equals ln of sec pi on 3 plus c, or ln of 1 over cos pi on 3 plus c, okay? And you really should get c to be negative ln2, which you just sub in to that equation over there, okay? So that's really question 7 over and done with. We're moving on to question 8, which is just really just using parametric equations and being able to integrate them and differentiate them, really. Nothing too extreme, although that question, you know, as with every last question on the paper, it's always going to be a bit of a tricky one, okay? So it's a nice question 7 leading on to a maybe not so nice question 8. Okay, so hopefully we'll see you next question. Obviously, see you. I say see you, don't I? I can look through the camera, it's pretty weird. Anyway, so that's the answer. Thanks for watching. We'll see you in the next video.